Chapter Triangles. Theorem 2.1. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Here we have to understand that there is a triangle and a line is drawn to one side of a triangle to intersect the other two sides in distinct points. In different points, the line will intersect the two sides, and this line will be parallel to the one side of the triangle. So what happens means the other two sides are divided in the same ratio. What we have to prove in this theorem? We have to prove that the other two sides are divided in the same ratio. This completes this theorem here. First, let me draw a triangle. And let me name it as A, B, C. There is a triangle, and if a line is drawn parallel, so we have to draw a line here which is parallel to the one side. We can draw a line parallel to AC. If not, we can draw a line parallel to AB, and even it is possible for us to draw a line for any of the sides, but conventionally we will be taking a line parallel to BC. So let me name it as DE. A line is drawn parallel to DE. So what is the data here? The data is in triangle ABC, DE parallel to BC. To prove, what we have to prove? Two sides intersects the other two sides in distinct points. If line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, the other two sides are divided. Here, the other two sides are divided in the same ratio. That is, this point is the point of intersection, whereas here in this side E is the point of intersection. This point of intersection divides this side and this sides in the same ratio. What is that ratio? So that is what to prove. AD by DB is equal to AE by EC. Next, to prove this, we have to make certain constructions. Let us make some construction. Here, what I will going to do here is, I will be joining BE and EC. So join DC and BE. So I will be joining these two lines here. These 2 points are joined, and then afterwards I will be joining DC2. Next, we will be draw EL. Here we will take a point L, and this EL will be perpendicular to AB. And DN. Here let me mark a point here N, as here it is L. That's right. DN perpendicular to AC. DN perpendicular to AC. So let me draw a line here which is perpendicular. This line should be perpendicular to AC, and even this line EL should be perpendicular. EL is perpendicular to the AB line. Next, proof of this theorem. So as usual, statement and reason. Statement, reason. Area of triangle ADE is equal to half into, here we have taken ADE, this triangle we have taken ADE. How to write this means, it is half into base into height. We will take this one AD as the base, half into AD is the base, into height. What is the height means, here there is a one perpendicular what we have drawn. That is the why we have drawn this perpendicular means, that's why we have drawn here. This is the perpendicular we have drawn. So this is the height, altitude, LE. No, we will take EN, ADE. We will take LE as the perpendicular, LE as the height. Next, let me take the reason is area of triangle is equal to half into base into height. Half into base into height. Area of triangle BDE is equal to, here BDE, this triangle, area of this triangle, BDE, this triangle. So here we will take, what is the base? Let me take BD as the base, of half into, BD is the base, BD is the base. So what is the height here? You should understand carefully here. This angle is an obtuse angle. So the height is nothing other than LE. LE is the height. Why means, you should understand carefully. If you draw this picture, what happens? Let me redraw this picture here. But in the exam, don't do this one. Let me simply write this one. It is not in the point of view of the examination, what I am writing here. So what happens? This one is DB. For your better understanding only, I am writing this one. Don't draw this one in the, so I will be drawing this one. Redrawing the picture. So what happens here? DB is this one, DB, whereas this point is E. This point is E. What happens here? As this is the obtuse angle. So if I draw a perpendicular to this line, means this line, so the perpendicular will be like here. So first of all, let me extend this line. Here comes the perpendicular. Yes, right? L. This one is the L. To calculate the area means, so we should understand like this only. So what is the base means? BD. BD is the base and EL is the height. That is LE, LE. For this also the same. The reason is the same. So let me take the ratio of these two things. So area of ADE by area of BDE is equal to half into AD into LE by half into BD into LE. Here half cancels, LE cancels, which will be equal to AD by BD. AD by BD. Let us note down as this as 1. So area of ADE by area of BDE is equal to AD by BD. Likewise, let us move on to the next triangles. Area of again ADE is equal to ADE area of ADE can be written as, now in the previous problem we have AD as base, but here we will be taking AE as base. So half into AE into, so as we have taken this AE as the base, the height will be, the altitude will be dn. dn is the base. So area is equal to half into base into height. So next one, area of, we will be taking CDE, area of triangle CDE is equal to half into, here CDE or CED, whatever it is, this is also an ear obtuse angle. So what happens, we will be taking this CE as the base, CE is the base. Next what happens, into height is dn, again dn, as this one we will be using here dn as the height. Reason is the same. So we will be taking the ratio of these two. So area of ADE by area of CDE is equal to half into AE into dn by half into CE into dn. Here half cancels, dn cancels. What remains is area of ADE by area of CDE is equal to AE by CE remains. Let us call this as 2. Here area of BDE is equal to area of CDE. You should understand here, area of BDE is equal to area of CDE, that is CED. BDE and CDE triangles are having equal area. What is the reason for this? Means these are the triangles on the same base DE and between the same parallels DE and BC. So we can write here that as the two triangles are on the same base, and between the same parallels, between the same parallels DE and BC. What is the same base means? Here DE is the same base. So these two are equal. As these two are equal, you can write area of ADE by area of BDE is equal to area of ADE by area of CDE. Therefore, 1 is equal to 2. So AD by BD is equal to AE by CE. This theorem is proved. This theorem is also called as Thales theorem. Thales theorem. And the common name is basic proportionality theorem, usually called as BPT, basic proportionality theorem. This is called as Thales theorem, basic proportionality theorem, and we commonly call it as BPT. This theorem is repeating in examinations of Karnataka State SSLC examination frequently. Now let us move on to the theorem 2.2, and it is called as Converse of Thales theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. You should understand this statement properly. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. As per the statement, a line divides any two sides of a triangle. So what is there here? First of all, the triangle is there here. Let me draw a triangle. And then the sides of this triangle is divided in the same ratio by a line. That has to be understood here. A triangle is there. Let me name that as A, B, C. And a line divides any two sides. As in the BPT, basic proportionality theorem, what we have done. Likewise, but conventionally we will draw here to a line here. But I am not sure that this is parallel. This line is parallel. We are not confirm about that one, but it has a line which divides, and let me name it as DE. This line divides the sides AB and AC in the same proportion. So what is the data here? Let me write the data in triangle ABC. We are sure that same ratio it has been given. So AD by DB is equal to AE by EC. What we have to prove here is then the line is parallel to the third side. So we have to prove that this line, this is the third side here, BC, DE is parallel to the third side BC. To prove what we have to prove here, DE parallel to BC. DE parallel to BC. Construction, we will make some certain construction to prove this theorem. Construction. Draw DE dash parallel to BC. Draw DE dash parallel to BC. So we will draw a line DE dash. Proof. Statement and reason. Yeah. AD by DB is equal to AE dash by AD by DB is equal to AE dash by DE dash C. Why means because of construction. We have constructed this one. Construction DE dash parallel to BC. Next, AD by DB is equal to AE by EC. This one is because given. It is given here. Let me call this as 1 and let me call this as 2. From 1 and 2. From 1 and 2. Here you see here AD by DB is there. So we can straightly write that AE dash by E dash C is equal to AE by EC. AE by EC. This is possible because of the thing axiom 1. The things which are equal to the same thing are equal to one another. The things which are equal to the same thing are equal to one another. That is axiom 1. Axiom 1 is there. So now we can say that, therefore we can say that AE dash is equal to AE and E dash C is equal to EC. Therefore, the point E dash coincides with E. Hence, DE parallel to BC. This is proved. This theorem is proved.